Assalamu alaikum wa rahmatullahi wa barakatuh. Bismillah ar-Rahman ar-Rahim. Math grade 7. Today we want to learn what the meaning of propositional and non-propositional relationships. Propositional and non-propositional relationships. What is the difference between propositional and non-propositional relationships? So we want to identify propositional and non-propositional. We want to identify the proportional and non-proportional relationship. What's the meaning of
السلام عليكم مستر، آسف على التأخير.
عليكم السلام ورحمة الله وبركاته. What's the meaning of proportional? Means we have two quantities are proportional if they have a constant ratio or unit rate. Proportional means we have two quantities are proportional if they have a constant ratio or a unit rate. This is the meaning of proportional. What's the meaning of non-proportional? Non-proportional are relationships in which this ratio is not constant. So what's the meaning of non-proportional? For a relationships in which this ratio is not constant. What's the meaning of equivalent ratios? Equivalent ratios. When the ratios have the same value. When the ratios have the same value. So equivalent fractions means when the ratios have the same value. So our lesson today, we want to learn what the meaning of proportional and non-proportional and equivalent ratio. So see with me now this video to know our lesson.
What? Still searching YouTube for math help? Are the videos from 2006 really helping? Aren't you tired of finding videos that aren't getting you any?
Hi, welcome to Math Antics. In this lesson, we're going to learn what proportions are and how we can use them to find an unknown value. The good news is, if you know about equivalent fractions, then you already know a lot about proportions. To see what I mean, let's start with the simple fraction 1 over 2, or 1/2. Now let's look at a pair of equivalent fractions, 1 over 2 and 5 over 10. These fractions are equivalent because even though they have different top and bottom numbers, they have the same value. 1 is half of 2, and 5 is half of 10, so they represent the same amount. Okay, but to understand what a proportion is, we need to start with a ratio instead. A ratio is basically just a fraction that's used in a certain way. If you don't remember what a ratio is, you can watch our video about them. So let's imagine that a student who's a really good reader can read one book in 2 days. We could say that the ratio of books to days is 1 over 2. One book per 2 days. All right, but what if our student reads books at that same rate for 10 days? How many books would they read? Well, if they finish one book every 2 days, then in 10 days, they'll have read 5 books. So that ratio would be 5 books per 10 days. Do you see what we have here? These are equivalent ratios. Just like the equivalent fractions, they represent the same amount, so we can put an equal sign between them. When we do that, we have a proportion. A proportion is just two ratios that are equivalent or equal. And one thing that's really important to remember, in order for two ratios to be equivalent, they not only have to have the same value, they also have to have the same units. That is, they have to be representing the same thing on top and on bottom. Let me show you what I mean. This is a proportion because the top numbers both refer to books and the bottom numbers both refer to days. But what if we change the top unit of the second ratio to be pizzas instead of books? 5 pizzas in 10 days is not equivalent to 1 book in 2 days. So even though the numbers are still the same, this is no longer a proportion. Or what if we keep the same units and just switch them in the second ratio so that the days are on top and books are on the bottom? Are they still equivalent? Nope. This is not a proportion anymore either. 5 days per 10 books is not equivalent to 1 book per 2 days. So the units have to be exactly the same for both ratios to form a proportion. All right then, so a proportion is a pair of equivalent ratios. But why do we care? What are proportions good for? Well, it turns out that proportions are really good for figuring out something you don't know from something you do know, and that makes them very useful. For example, suppose that a student who is a good reader has a big stack of books that they want to read, 23 books to be precise, and they want to know how many days it will take them to finish. How do we figure that out? Well, let's start with what we do know. We know that they can read 1 book in 2 days, so let's take that ratio and set up an equivalent ratio for 23 books. The key in setting up that equivalent ratio is to make sure that the units are the same as the first ratio, books on the top and days on the bottom. We know that the number of books that they want to read is 23, so that goes on top. But the number of days it will take is unknown. So instead of putting a number there, we're going to put the letter in there temporarily to stand for the number that we don't know. This is how you'll usually see and use proportions in math. 3 of the proportions numbers will be known and 1 will be unknown. Fortunately, if you know 3 of the numbers, you can find the missing number easily using a procedure called cross-multiplying. Cross-multiplying is just a shortcut way of doing some basic algebra to rearrange our proportion so we can find the unknown number. To do it, we first start by writing down a new equal sign because cross-multiplying will give us another equation. Next, imagine that a crisscross shape, like an X, is overlaid on the proportion. This cross shape tells you which numbers to multiply together on each side of the new equal sign. 1 and n will be multiplied together on this side of the equation, and 2 and 23 will be multiplied together on the other side of the equation. Oh, and as long as you follow the crisscross guides, it doesn't matter which pair goes on which side. Okay, so our proportion has been rearranged. Now what? Well, on one side of the new equation, we have 2 numbers being multiplied together. The next step is to go ahead and simplify by doing that multiplication. 2 times 23 equals 46. But what about the other side of the equation? That has a number being multiplied by our unknown letter n. How can we multiply when one of the numbers is unknown? Actually, we can't. Fortunately, we don't need to, because we're just trying to figure out what our unknown number is. What does it equal? In other words, we need to keep rearranging our equation until the unknown value is all by itself on one side of the equal sign, and all the known values have been combined on the other side of the equal sign. Then we'll have found the unknown. In this problem, getting the n by itself is easy because it's just being multiplied by the number 1. And what happens to a number when we multiply it by 1? Yep, absolutely nothing. 1 times n is exactly the same thing as just plain n. So we can just ignore or get rid of the 1. And look, our equation is now n equals 46. That means that we know what n equals. We've figured out what the missing number of our proportion is. If our student can read 1 book in 2 days, then they can read 23 books in 46 days. We've used a proportion to solve for an unknown. All right, let's see another example of using a proportion to find an unknown. This one involves a map. Have you ever noticed that maps are a lot smaller than the real-life places that they show? A map is a good example of something called a scale drawing, which is just a drawing that's either larger or smaller than the real thing it depicts, but it's still in proportion to that thing. For example, this map of Hawaii is a lot smaller than the actual Hawaii. But even though the map is smaller, it's still proportional to the real island. And there's even a scale on it to show the relationship between the 2 sizes. It says that 5 centimeters on the map is equal to 9 miles on the real island. Okay, suppose that we want to know how many miles it is from the Hawaiian volcano, Mauna Loa, to the city called Hilo. We can set up a proportion to figure that out. The ratio that we already know is 9 miles per 5 centimeters. Now we just need to set that equal to an equivalent ratio that has the unknown distance in it. Because we have the map, we can use a ruler to measure how many centimeters it is from Mauna Loa to Hilo. It looks like about 20 centimeters, so the bottom number of the equivalent ratio is 20 centimeters, and the top number is the number of miles, which is unknown. Again, we'll just use the letter N to stand for that missing number. To solve this proportion for the unknown number, we use our cross-multiplying procedure. First, we write a new equal sign, and then we imagine the crisscross to show us what we multiply together on each side. On the first side, we have 9 times 20, and on the other side, we have 5 times n. On the side that has two numbers, we can go ahead and simplify. 9 times 20 equals 180. On the other side, we have 5 multiplied by our unknown value, n. We can't multiply that, but we don't need to. Instead, we want to get the n all by itself. How do we do that? Well, we can't just ignore the 5 like we ignored the 1 in the last problem. Instead, to get the n by itself, all we have to do is divide both sides of the equation by the number that n's being multiplied by. In this case, that's 5. So on the first side, 180 divided by 5 equals 36. And on the other side, 5 times n divided by 5 is just n, since the 5's cancel out. There. Now we know what the unknown value in our proportion is. 36 equals n, which is the same as n equals 36. That's the number of miles it is from the volcano Mauna Loa to Hilo. Alright, so in this video, we learned that a proportion is a pair of equivalent ratios. And we learned how we can set up a proportion that has an unknown number and then find out what that number is by cross-multiplying. Proportions are really important. If you understand how they work, you can use them to solve all sorts of real-world math problems. And the best way to understand them is to practice what you've learned in this video by working some problems on your own. Thanks for watching Math Antics, and I'll see you.
So this is the meaning of proportional and non-proportional and equivalent ratios. We have this example. Identify proportional relationship. We have this table. We want to know if the ratios inside this table proportional or not. Proportional or not. How to know? It shows any two ratios from this table. For example, I will take 1 over 4, and 3 over 12, and 3 over 12. Now, how to check is it proportional or not? Take 1, multiply by 12. 1 times 12, 1 times 12, 1 times 12 equal 12. Now, take 3, then multiply by 4. 3 times 4 will be 12. 3 times 4 will be 12. As you see, we have here 12 and we have here 12. The same amount, the same answer. Means when you multiply the two sides, 1 times 12 equal the next size 3 times 4. Means this is proportional. This is proportional. Why? Because we have 1 over 4 equal 3 over 12. Means this is equivalent ratios. This is equivalent ratios. When you have equivalent ratios, means you have proportional relationship. Means you have proportional relationship. I will repeat. How to know? Is it proportional relationship or not? Choose any two ratios inside the table. For example, I will take 1 over 4, and 3 over 12, and 3 over 12. How to check? Is it proportional or not? If the ratios have the same value, means we have equivalent ratios. If we have equivalent ratios, means this is proportional relationship. How to check? Take 1 and multiply by 12. The two sides here. 1 times 12 equal 12. Then take 3 and multiply by 4. 3 times 4 equal 12. This is cross multiplication. Cross multiplication. Do cross multiplication. If you get the same answer, means you have equivalent fraction. Means you have equivalent ratios. Why equivalent ratios? Because 1 over 4 equal 3 over 12. When you have equivalent ratios means the relationship here what? Proportional relationship. The next example here. Identify proportional relationship. How to know? Go to the table and choose two ratios. Take 1 over 5. Take 1 over 5 for example. Then take 3 over 18. 3 over 18. How to check? Now, 1 times 18, do a cross multiplication. 1 times 18 equal 18. 3 times 5 equal 15. The answer here 18 and the answer here will be 15. So we have here different answers. Means 1 over 5 not equal 3 over 18. 1 over 5 not equal 3 over 18 means the ratios here not equivalent because doesn't have the same value. So that's mean non-proportional relationships. So this is our lesson today. How to know if we have proportional relationships or not non-proportional relationships. Who has a question now?
Mister, you will put this PowerPoint and the video in the Microsoft Teams to revise it?
Inshallah, God willing, inshallah, I will put it. Who has a question? What is the name of our lesson today?
The
Mister, I have a
relationship
question.
of the
Relationship of the
Yes. What is the name of our lesson today?
proportional relationship of
Proportional and non-proportional relationship. Proportional and non-proportional relationship.
proportional
Proportional
and non-proportional relationship.
What we learned today? Proportional, non-proportional, and equivalent ratios.
ratios.
Yes, we have. Do you have any question?
No.
Okay, let us do some exercise now. Look to this table. Inside this table, we have many ratios. And the question here, use the table of values. Write the ratios in the table to show the relationship between each set of values. Just choose two ratios. For example, here we have 1 over 15 and 4 over 60. Okay, I will take the first one and the last one. So we have 1 over 15 . 1 over 15 . And the second one, the last one, 4 over 60. 4 over 60. We want to identify, is it proportional or not proportional? Where is Hamdan al-Amiri? Where is Hamdan al-Amiri? Hamdan al-Amiri. Okay, where is Duwais?
Mister,
Yes?
ما فهمت الدرس.
Listen to me to know. Where's
Sir,
Falah?
can I go to the bathroom?
Okay, you can. Where is Falah? How to know our lesson today? How to know is it we have proportional relationship or non-proportional relationship? What I do a cross multiplication to know are the two ratios here equivalent or not. So take the first across 1 times 60. Is it 1 times 60? Well, what? 1 times 60 equals 60. Cross multiplication, 4 times 15. Is it 4 times 15 equals 60? Yes, 4 times 15 equals 60. That's mean 4 times 60 equal 1 times 16. Because here we have 16 and here we have...
Mister, I will go to the bathroom and come back, okay?
Answer, okay. So, we can write now 1 over 15 1 over 15 equal 4 over 60 equal 4 over 60. So that's mean this relationship proportional or not proportional? Proportional, huh? So we have here proportional relationship. سلام. خدته. Proportional relationship. So this is proportional relationship because we have here equivalent fraction. So here we have equivalent fraction. Right. The second example, prepare your notebook or any paper and work with me, please. Now we have this table, the second table. I want from all to tell me, is it relationship or not relationship and why? Is it proportional relationship or not proportional or non-proportional relationship and why?
Mister, it's not relationship. Mister,
Why?
because when you do the crossing between them, the answers will not be the same.
Excellent. What's your name?
عبد الله محمد الجابر.
Okay. Choose any two ratios from the 4 ratios here. For example, we will take 1 over 11 and 3 over 27. So we have now 1 over 11. 1 over 11. Over 11. Three over 29. 3 over 29. Now, how to check? Do a cross multiplication. Is it 1 times 29 equal 29? Is it 3 times 11? Times 11 will be what? Will be 33.
33.
We have 29 and here we have 33. So this is different. This is different. That's mean 1 over 11. 1 over 11. So here 1 over 11. not equal. Not equal 3 over 29. 3 over 29.
Hello, Mr. I'm Salim Adda.
So, this relationship proportional or not proportional now? Proportional or not?
Proportional.
Not
proportional. Not proportional.
yes. Why? Why? Because
They are not
because 11 times
because they don't have
because
the
33.
the ratios here.
Because the equal number.
Ratios here because the ratios here not equivalent. Now it's clear now for all. Do you have any question now?
No.
Right. Let us to take attendance.
7A.
Ahmed here. Salim.
مستر أنا هني.
حمد أحمد.
مستر أنا هني. مستر أنا سالم. أنا هني موجود. سالم المنهالي.
حمد سعيد موجود.
موجود مستر حمد سعيد.
حمدان علي الهجري. حمدان علي الهجري.
مستر
اللي سمع اسمه بإمكانه يغادر. حمدان علي الهجري. أبسنت.
مستر أنا بإمكاني أقادر. سالم هداء.
بس يطلع اسمك. زايد سالم. زايد.
مستر أنا موجود.
موجود أستاذ.
اوكي. سالم هداف موجود بإمكانك تغادر سالم. عبد الرحمن موجود. عبد الله مانع. علي حمد.
مستر طلع.
موجود.
اللي طلع اسمه بإمكانه يطلع. عيسى.
الله يسلمك مستر.
مع السلامة. عيسى.
موجود مستر.
فلاح.
موجود أستاذ.
منصور أحمد.
موجود أستاذ.
منصور راشد. منصور نايف.
مستر عبد الرحمن موجود.
ميلاد موجود. هزاع موجود.
مستر أنا منصور نايف موجود.
موجود. أنا ميلاد موجود. أستاذ محمد عمر موجود.
خلفان. خلفان
موجود.
خليفة.
سبعة يطلع.
اللي طلع اسمه يطلع. خليفة. خليفة عبيد. دويس. 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 أبسنت. ياب. سالم جمعة.
موجود أستاذ. موجود.
سلام أستاذ.
سلطان علي. سلطان خليفة.
موجود أستاذ.
سيف.
موجود أستاذ.
عبد الله محمد الجابري.
موجود.
فارس. محمد سالم.
موجود.
عبد العزيز.
أستاذ موجود.
محمد عمار. محمد عمار.
أستاذ أنا موجود. فارس.
حاضر أستاذ.
اوكي. محمد عمر.
موجود.
منصور.
موجود.
منصور علي.
أستاذ أنا دويس. حاضر. موجود.
موسى.
موجود أستاذ.
منصور محمد.
أستاذ موجود أنا. منصور محمد. أستاذ.
نعم.
محمد الحياني موجود بس ما عنده مايك.
اوكي.
أنا بعد موجودة.
طيب.
أستاذ موجود.
طيب. Look to the exercise number 3, and I want from all to check, is it proportional or not? Is it proportional or not? Work and answer me. Work and answer me. We have now Abdullah Tamimi and Khalifa and Muhammad Al Hayyani. Who can answer me? Is it a proportional relationship or not? Who can answer me? You can choose any two ratios. For example, I can take 2 over 48, 2 over 48, you can take, for example, 3 over 72, 3 over 72. Now, how to check cross multiplication? Take 2 times 72. 2 times 72. Well, 144. Take 3 times 48. 3 times 48 equal also 144. So that's mean 2 times 72. 2 times 72 equal 3 times 48. So I can write now 2 times 48, 2 over 48 is equal 3 over 72. 3 over 72 means we have equivalent ratios. So means we have a proportional relationship or non-proportional. So means we have proportional relationship. We have proportional relationship. Okay? Right. The second example here. Look to this table. Look to this table, number 4. And tell me please, is it proportional or non-proportional? Is it proportional or non-proportional? Right. I can choose 1 and 2 ratios from the table. So I can write now 1 over 0.99 1 here 0.99. And the second ratio 2 over 1.98. 2 over 1.98. 2 over 1.98. Now, how to check? Do a cross multiplication. Take 1 times 98 equal 1.98. 2 times 0.99 times 0.99 also 1.98. So the same answer. That's mean one over 0.1 over 0.99 2 over 1.98. So the relationship now between the ratios here in the table, proportional relationship.
Mister, how is it proportional relationship?
Do a cross multiplication. 1 times 1.98 equal 1.98. Then do 2 times 0.99 equal 1.98. Look, if you have the same answer, means you have proportional relationship. So that's mean this ratio and this ratio equivalent because they have the same value. The last example here, as you see here, 1 times 29. Do a cross multiplication. 1 times 29 equal 29. And 3 times 11 equal 33. Now you have different answer. Means we don't have equivalent ratios. Means we have non-proportional relationship. So this is our lesson today. Thank you for your listening. Have a nice day. See you tomorrow, inshallah. Assalamu alaikum wa rahmatullah.